I'm going to tell you a story. I want you to take your 5 grain. I'm going to tell you a story, and I want you to model it. Okay, so there were 3 bears playing in the park. And one more bear arrived to play with them. How many bears are playing in the park now?
4 bears.
4 bears. And she built it too.
Jody needs some help there.
Jody needs some help. Yeah, she needs to count. Stop talking to count. Okay, and so we would have kids do this kind of a story, and then we'd have them come up and model it, so they could say, you know, I started with 3 bears in the park, and then one more big bear came along. Sometimes we let them do the new addition in a different color, so that they see the 2 parts and the whole. Okay? So there were 3 bears, and there's 1 new bear, so now there's 4 bears. And some kids will need to recount, and that's okay if they're in grade primary 1. By the end of grade 1, we hope that they can count on. Some of the things that we do for counting on are things like talking about neighbors, like who's 3's neighbor, like 3 and 1 makes what, or who's 1 less than 3, and things like that. So we play 1 more, 1 less, 2 more, 2 less games, right? Who's 2 away? Who are my 1 away neighbors? Who are my 2 away neighbors if I live on the number line at 4? Right? Who lives on either side of me? Things like that. So we want kids to get that notion of number lines and patterning with the number system. And it's actually most appropriate for them to learn the number words even before they learn the quantities. So we want them to be able to count to 10 before they know how much 10 is, right? Or anything before that. Let's try a new one.
Story?
Yep. We're going to do another story. There were 4 children playing by the pool. Somebody's mom came and picked up 2 of them and took them home. How many children are playing by the pool now? 2 children. 2 children. How did you do that?
2 ways.
Okay. Put 4 people on. And then you took 2 away. Sometimes it's way more fun to have actually those like little counting bears and little animal creatures and stuff. You can get some really neat ones. We don't have any because they're expensive. And 2 color counters can be used from grade primary to grade 12. So, but like in some primary classrooms, you'll see like little counting bears and like little creatures that are different colors and patterns and things like that that you can use. These kids can model. And then after you've done some story modeling, you can get them to model stories to each other too, right? And practice and see if they can figure out the answers and things like that. I'm going to give you a hard story now. Yeah, this one's just for you. Okay. There were some children playing in the park. One more child came, and now there are 4 children playing in the park. How many were there to start?
3.
That is a tricky, and we would never give that to grade primaries because it's linguistically challenging more so than mathematically challenging. But that's a special kind of problem where we have sort of an arbitrary start number that we don't know, plus 1 more equals 4, and we have to figure out what that was. So in grade 1, we start looking at structures of story problems. And when we do structures of story problems, it's Like, typically when we do an addition question, you say, well, I had 2 of this, and then I put 3 more, so now I have 5, right? But that's only one kind of addition problem. That's one where we know the two amounts initially, the initial and the change, and we're looking for the result. But sometimes we don't know the initial one, we know the change, and we know the result, and we have to figure out what the initial was. Or sometimes we might say, I had $2, and my grandma gave me some more, and now I have $5. How much did my grandma give me? $3, right? So this is one where we know the initial, we don't know the change, we know the result. So there's different structures, and talking about all these different structures with kids is really important because we want them to know that when they're confronted with different contexts, they can still use addition, right? And the same is true for subtraction as well. Okay, there's different ways to think about subtraction. So if I said to you, I had 3 counters, but I lost some, and now I only have 1 left. How many did I lose? 2, right? So again, or I had some counters, or I had some marbles. I lost 2 at recess, and now I only have 2 left. How many did I have before recess? Are you sure about that?
What did you say?
I don't know. There's only like 3 people who answered. But I had some marbles. I lost 2 at recess, and now I only have 2 left. How many did I start with? 4. Okay. So just like with addition, we can tell stories where different pieces are missing, and that's going to help our grade 1s and 2s to broaden their understanding of when we use addition and subtraction. Right? And sometimes we can use a think addition strategy to solve a subtraction problem, like the one we just did. I had some, I lost 2, I have 2 left. How do you get that? Really, you got to add the 2 back in, so you're doing a think addition strategy to get your answer, even though it's a subtraction. Let's look at some 10 grams.
If grade 3s, for example, can't do that,
What?
I
You
mean,
guys are funny. Make fun of me.
hypothetically, in my practice,
Hypothetically, in your practicum, if your grade 3s can't do that?
they couldn't do that. Like when you had one like 3 plus what equals 7. They weren't using these that I know of. I didn't see these, but she taught them some other strategies. But the majority of them were just like, I don't know how to get that information.
Yeah.
So you're saying grade 1 and 2, and I'm thinking,
Yeah.
if they can't get it in grade 3, what does that mean for 4 and 5?
Right. Yeah. That's an important thing. We have a lot of kids who, my argument would be is that probably somebody didn't spend enough time playing with 10 frames in grade 1 and 2 and doing kind of different structures of story problems. So now your grade 3 teacher is trying to teach them those strategies mentally, and they don't have the visual to do the mental. And there's also a huge problem with the notion of equivalence, because there are a lot of kids who think this means, they really think this means and then the answer, right? And that makes the answer. So when they see something like 3 plus blank equals 7, they don't really think about equivalence. They want to make an answer. So sometimes they'll put 10 in there because they take the 3 and the 7 and they add them together and make 10, right? Or they'll do things like this. And they'll put 7 in there, right? Because they think 3 plus 4 makes 7, right? Because they don't think of it as being balanced. So one of the things that we need to do with kids is, just like you were looking at that arrangement before, if I have 3 and 4 and 2, what has to go on here to keep it balanced, right? And so we need to do some balance work with kids and get them to understand that when they see this equal sign, what it really means is a balance. These 2 sides are balanced. They're equivalent. They're the same quantity. And so if we went back and looked at kind of these models we were looking at before, we could have done expressions like 6 plus 1 equals 5 plus 2. equals 4 plus 3, right? And do things like that. We need kids to have visuals in order to be able to do some of these things, and if they don't have the visuals, oftentimes they get bogged down and they get confused. The other issue is they might not have spent enough time with the number line. So if I'm at 3, how many more jumps do I need to get to 7, right? And so then it's 4, 5, 6, 7. So the experience playing with number lines can help to build that, but if they're in grade 3 and they can't do that yet, they need to go back and have those experiences. They need to take the 10 frame out and say, I have 3, how many more would I need to add to make 7? Or, I'm at 3 on the number line, how many more do I need to go to make 7? Because so many of their future mental math outcomes are going to depend on that, and it would be much better to slow down and fix it at grade 3 than it will be to slow down and fix it at grade 7. I taught grade 10 for many years, and I used to spend a whole lot of time reteaching stuff, right? I taught like a 10 plus course, which is like the full year course, 1 credit but extended over 2 semesters. And I spent a lot of time fixing pieces. So then after that I taught grade 8 for a while, and I spent a lot of time in grade 8 fixing pieces because I knew there'd be fewer pieces to fix in grade 10. We're going to do this now. But the sooner you notice, the sooner you fix it, right? So if you notice gaps, then you need to be doing things to rebuild it or to address it or whatever. Because kids in grade 3 should be able to tell you what goes with 3 to make 7. And if they can't, then they need more concrete experiences. There is a horrible myth out there called the if you need them myth, right? If you look at the Math Makes Sense textbooks, it will say, model this with base 10 blocks if you need them. There is no if you need them. If you can't model something, then you don't understand it, right? If you can tell me that 3 plus 4 is 7 and you cannot build me a model to show that, you do not really understand that 3 plus 4 is 7. You've just memorized that phrase. Right? It's like when we get kids to memorize their addition chart or their multiplication chart, right? I know all kinds of kids who can tell me 3 times 4 is 12. They cannot draw me a picture to model this, or tell me a sentence to model this picture. I've done assessments with kids where one of the questions is, what is 3 times 4, what is 2 times 5? They answer those fine. The other question is, blank times blank equals blank. Write an expression to model these 2 pictures of 3. And they cannot do it. They frequently do this. Because they can count to 3 and they've memorized 3 times 3 equals 9. They don't know that multiplication means sets off. Right? And so you'll see that, and that's what happens when we take away concrete materials too soon, and when we think that it's okay to just rush kids through by telling them instead of letting them discover it. Right? Kids can memorize their times tables and their addition facts till the cows come home. If they can't visualize a model that shows that, they're never going to have that flexibility. Yep.
This concept seems like a really big debate because in my class this morning, our professor preached to us that it was all about memorizing.
What?
Like that.
Or the middle school method.
Yeah. Like it was all about like if kids can memorize it, they're good and like.
I think that's all we do. I actually heard a big,
This is gonna lose it.
big fight about that class. Like,
Is anyone else in my class?
I memorized my timetable, but I understood it.
I heard about it, but I.
Is the table gonna go?
She's not happy at all.
Box and bugs.
But some, sorry.
I'm sure Grant can buy the room, but we can fix 72 people.